this is the lens part of the lab. So the first part, you're going to
This
take
is Light Rays and Lenses, Lab 13.
Yes, Lab 13, Light Rays and Lenses. Thank you for clarifying. You're going to take the plate and put it on top of this stand. And then, very importantly, you're going to take this slit piece and you're going to use the magnet to hook it onto the stand. And you're going to place that right in front of your light source. Actually, let's take this crosshatch off. Right in front of your light source. And in front of that, you're going to take the slit mask and you're also going to put this right on top. And so you only get one major ray of light coming out. And then you're going to set it up. You might have to adjust it a lot so that the ray of light falls along probably the 90-degree angle line. And then you're going to take your cylindrical lens, and for the first part, you're going to put it like this, where it's lined up with the normal line. And this is air to plastic condition, where first it hits the flat side and then the round side of the cylindrical lens. And then what you're going to do is you're going to start here, and you're just going to move it in 10 increments of 10, and you're going to measure, this is going to be your incident line. So incident angle where the ray hits when it's first coming out, and then here's going to be your refracted angle, the angle which is going to be over here, hopefully roughly in the middle of the ray. And then you're just going to continue moving it in 10-degree increments until you get to 0, and you're just going to record all of the incident and refraction angles that you measure until you get to here. And then you're going to do the exact same thing, but you're going to turn, this cylindrical lens around. So basically, you're going to do the exact same thing. It's going to
Should this guy be here or should it be there?
I believe it should be here, where the this should be at the very front of the line. And again, you're going to move it in increments of 10 and see both the incident and the refraction angles, and measure both of those every time and record all of those until you get to 0.
For the lens, I think it's supposed to be 75.
And then how do you do the calculations in this lab?
For this one, you're just going to graph the sine of the incident angle versus the sine of the refracted angle, except for part 1, where it's facing this direction, air to lens. The incident angle is going to be your y-axis, and refracted is going to be your x-axis. But in the other condition, plastic to air, it's going to be flipped. Your refracted angle is going to be the the y-axis, and the refraction is going to be your x-axis. Yeah, it's flipped the opposite way around. And then there's the other part, which is the mirror. And you're going to need 2 of these stands. So for the mirror part, it's kind of difficult, but you're going to take your mirror and you're going to place it here, and you're going to place your object onto the light source so that it creates an image. And then you're going to take your viewing screen and you're going to put it here so that there's light can pass through and then hit the mirror, and you're going to try and focus the reflection from the mirror. Actually, it might be this direction. Yeah, you're going to try and focus the reflection from the mirror onto this viewing screen. Also, the mirror has to be focused this way and not this way. This way doesn't work. This way has to be pointing towards the light source. So you can kind of see it's coming into focus right here. Let's let a little more light in. There we go. Now you can see more light. You can see that it's coming into focus here. So then you're going to find your object distance, which is from here to here where the image is, and then your image distance, which is going to be from the mirror to where the image is. And you're also going to measure the height of your image as well as the height of the object. And then you're going to calculate the magnification, both by doing the height over of the image over the height of the object, and then also the height of the, the object length over, the image length over the object length, but the image length has to be negative, so it's negative I over O. And then for the lens, you're going to do a very similar thing. So you're going to have the lens, but you're going to put the image on this side of the lens. And you're also going to, see where it comes into focus. And then you're going to measure, again, the height of your image versus the height of your object, and the distance of the object versus the image distance. And then, again, measure the height of the image over the height of the object, and then the distance of the image negative over the distance of your object. And that is pretty much it.
And then, real quickly, I'm going to show what the board shows. This is from lab. Light rays and lenses. And this is for lenses and the eye.